So this is the remediation for 5.2, which is really extended graph analysis. And in each of these questions, we're going to ask you to do a whole bunch of things. So find all the x-intercepts, find any maximum or minimum using your calculator, domain and range intervals and behavior, and then increasing and decreasing behavior. So there's only 4 of them, which means I'm only going to do 1 of them. And I'm going to look at number 3. Now this does require you to get a picture of it from a calculator. So the first thing I did was I grabbed my calculator and I typed the function into y1. I hit, sorry if you can't see it, I hit zoom 6 to bring it to a standard window, and I got that picture right there. So we have a quadratic, which we knew we'd have, a parabola that opens upwards, and I would transfer that kind of to my paper, and you could use your ordered pairs if you'd like off of your table to get a good picture of it. But what I'm really interested in is that minimum. So I'm going to go ahead and find that minimum by doing second trace and then choosing the minimum finder. And then when it says left bound, let me bring back here, they want you to get your cursor to a moment right before the minimum happened. So I can tell 1, 2, 3, the minimum's about at x equals 4. So I'm just going to say like x equals 2. I'm just going to type it, but you could definitely scroll so you bring it over here. And then to the right of the minimum, I'm going to go like x equals 6. It's definitely after the minimum. But again, you can scroll. Notice the 2 vertical lines that show up. The minimum that we're trying to find is in between the 2 of them, so we're in the right domain. So hit enter when it says guess. Oh, good guess, Abruzzo. That is exactly, this is pixelation issue. This minimum is located at 4, -3. So, go back to my paper. And I'm supposed to graph an accurate picture, but since this is so tiny, I'm not going to be able to. But we're going to pretend. And then, yep, I'm going to, oops, okay, missed my point totally. So pretend you have a good point. You probably plotted really accurately. And I go back to that list. What do they want from me? Oh man, the zeros. I did not find the zeros. Okay, back to the calculator. So, on my calculator. My x-intercepts, they're not going to be pretty numbers, right? There's a weird one here at what, 2 point something? And then this guy is at like 5 point something. So, let me extend my screen. Well, I guess I can't extend my screen while I'm live recording. Silly me. I'm going to go to second trace. To find the x-intercepts, I have to use the 0 finder. So number 2. Drag it back over now. So when I refer to left bound or right bound this time, I'm going to find this x-intercept first. So left bound, or before the x-intercept, would be at x equals 1. You could use your left arrow. I really wish I had a bigger recording screen right now. The left arrow, you can scroll like this. It takes a while for me, but you guys are a little faster. So left bound, hit enter, or you could have just guessed a number that was before it. And then for right bound, get a little after it, enter. And then as long as you're in between there with the right thing you're trying to find, hit enter. And one of our x-intercepts is at, I'm going to round to the hundredths, 2.27, 0, I'd write down. So then you pull up second trace again, and you pull up the 0 finder again. And this time I want to find this x-intercept. So we know it's like 5 point something. So when it says left bound, I'm just going to type like 5 as a guess. That is definitely before the x-intercept. And then 7 is like definitely after it. So I'm going to hit 7. So I like hopping. It's a little quicker for me. And then when it says guess, you don't have to type anything. Just hit enter. Alright, pretty good guessing. 5.73. So back to my slides. Come on. I already forgot what they were, but the good news is I've put an answer key on your remediation, so I'm just going to steal that. Ugh. And I, of course, didn't graph properly, but you guys will. Alright, so your zeros, we're at, oh, I only rounded to the 10th, sorry. 2.3, 0, and 5.7, 0. Yeah, I did not graph that right at all. Oh well. Now the minimum, 8 years later, remember how I said find the minimum and then I never wrote it down? Pretty sure it was at the ordered pair 4, -3. But this is on your calculator, right? So if you need to go find that, you sure can. Next, I want to do domain and range. So any polynomial, the domain is like a super easy question. Domain goes forever from -infinity to +infinity. Your range, however, on even degree polynomials like quadratics and quartics, your range either starts or stops at a certain value. So your range in this case starts at a feel like I got that point backwards. Maybe not. I think I just graphed it stupid. All right, -3, and then it goes up forever, so it goes up to infinity. Notice my use of a bracket on the range because it does have an ordered pair, and therefore we need to start with a bracket. End behavior, everyone's favorite. Oops, I should use a different color. That'd be confusing. Nothing confusing about this, right? So end behavior is that lovely template that we have to keep writing down. And the template is just asking us to investigate what happens on the very far left side and the very far right side. So if you can memorize the template, awesome. If you know what it means, that's what you need to do. As x goes to -infinity is just a very fancy way of saying the left side. So on the left side of your graph, it's going up, which means you write infinity. And then as x goes to +infinity, that's a very fancy way of saying the right side. So on the right side of your graph, it's also going up. So we say +infinity. So the only thing you write here for end behavior is just a fancy notation for either up or down, because our polynomials are going to go either up or down on either end. And then I think there's two more questions, excuse me. Increasing and decreasing intervals. Oh my gosh, I should have wrote smaller. So this is where, I'm going to redraw this a little bit. I need to bust out some colors big time. I need to treat this like a roller coaster. Yeah, sure. Something like this. This is my, oh my gosh. I quit. Try that again. Okay, not much better. First thing I'm going to do is I'm going to erase my arrows, because I think the arrows confuse kids. And I'm going to think of it like a roller coaster. So, starting on the left side, my roller coaster is decreasing until it hits this ordered pair. So remember, this is the ordered pair 4, -3. And what I like you guys to do, I like when you highlight the x value, because what we're about to give our teacher is a domain interval, so you're only allowed to use x's. And then the rest of the roller coaster is increasing, right? It's going up, 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 up. So when I come up with, oh my gosh, I really should have wrote this better. When I come up with the increasing and decreasing interval, the roller coaster is decreasing from -infinity until it stops at 4. So we say -infinity to 4. Always use parentheses on increasing and decreasing intervals because, oh, I wrote that in the wrong spot. That was decreasing. Decreasing from -infinity to 4. Because at the bottom of the roller coaster here, it's actually not doing anything other than just staying flat and horizontal. All right, now from 4 and then forever, this is the worst roller coaster ever. It just keeps increasing forever and ever and ever without bound. So the key to that question is that you only use the x value of your minimum or your maximum to indicate that you have a change from increasing to decreasing. All right, keys on the back of your remediation. Please practice, practice. You might need to come in and use my calculators. Or remember, you guys can use emulator calculators on your phones. The Android version is Wabbit, EMU, W-A-B-B-I-T. And then the Apple products have their own graphing calculator. I believe there's a free one. So, all right, good luck.